Alright, and this is Physics 2, Lab 2. So for introduction and principles, so we're going to be measuring the magnetic field at distances from a bar magnet. We're going to do this by using a magnetometer on the phone and then placing the bar magnet various ways in orientations. And we're going to create a magnetic field in GlowScript using the measured moment, dipole moment calculation. And then we're going to run the simulation and yield a result that we can use. So some of the principles are involved here. We're going to use these two equations to isolate mu and then plug it back in. So based on the distance from the magnetometer chip, measure the different magnitudes from the magnetic field. We put that in the Excel file and we find the slope. So the slope is, it's a little bit off in the picture, but the result is n is equal to negative 3.02. And then we have the rest of the numbers. U mag is equal to 3.34. Then we're able to plug all of these numbers into the dipole moment equation and get a number that we can use for our GlowScript simulation. So some of the observation questions from the experiment. So when the magnetometer is far away from the magnet, it measures as near zero magnetic field in the x direction. This is true. As it moves closer to the magnet, the measured x component of the magnetic field decreases. This is false. It has no effect on the measured x component. We can clearly see from the graph that this is false. And as it moves closer to the magnet, the x component increases. That is true. So for the experimental model, we had to code in the equation for the dipole moment, and then we were able to input our parameters in there and return the correct answer. And then we are able to plot this into the GlowScript and show a simulation of the magnetic field and the magnitudes at different observation points and different angles. So the experimental model yielded a result of 3 times 10 to the negative 5th Tesla, and the computational model was 1.7 times 10 to the negative 5th Tesla. So some of the possible error was external magnetic fields were present in the surroundings. So this could be any various number of materials that carry both charge and magnetic field, and then there's also software inaccuracies that are possible within the magnetometer deployment. So these are third-party kind of unverified applications, and we can't always trust that those type of results 100%. So to answer the what if questions, if we had to orient the setup to compensate for in the north, that's what we did. But if we hadn't done that, we would have to adjust our axes on a micro level and adjust the frame of reference in the problem. We would have to calculate the same calculations, but we would have to adjust the angles, maybe use the opposite ones or whatnot. And so if there were two identical magnets and we redid the experiment, from our calculations, the magnitude would increase, but the direction would stay the same. So the measurements would be different, but the magnitude would increase.